Self-replicating machines have consumed Earth, controlled by an out-of-control AI. They've mined asteroids and planets to build more and more of themselves. They've drained stars dry to fuel their expansion. They've swallowed entire galaxies. And they won't let up until every single crumb in the universe is mined, processed, and converted into machines just like them. Hold on, does it have to be this way? Surely a super intelligent AI deciding where these probes go and what they do would be able to keep us safe. But in just 48 hours, our only home, Earth, could be reduced to a machine-dominated hellscape. And the scariest part is that we might actually be less than a year away from total destruction. Yeah, the threat is more real today than it's ever been, and it might already be too late. So, what if AI destroys us by accident? A surface covered in a writhing set of gears and gnashing wires, sputtering as the last remnants of energy are consumed to replicate just one more machine. And this story plays out infinitely across the entire universe, until the universe becomes completely still. This is the logical endpoint of John von Neumann's concept of the self-replicating machine, conceived in the 1940s. He asked the question, what if you could build a machine that could build an exact copy of itself? Well, then you could have an infinite number of these machines. But would this even be possible? What would it take to build a self-replicating machine? Well, we could start with something familiar, a common machine that already exists. There's probably one at your local library, a simple 3D printer. Now, regular 3D printers lay down layers of liquid plastic, one on top of the other, to create three-dimensional objects. They're guided by coded digital instructions and can print anything from miniature toys to rocket nozzle prototypes. They've also got the capacity to print objects with complex internal structures, like synthetic bones. Now, industrial 3D printers use lasers to fuse powdered metal and print objects out of metal. So, these relatively simple devices are a perfect starting point to design a machine that can replicate itself. Give it some additional functionality to source materials from its environment and tools to process that into ready materials and to assemble the finished parts, and, well, theoretically, we should be able to program a 3D printer to print another printer just like itself. How close are we to that today, though? Could a 3D printer realistically print itself? Well, to start, it would have to print its own structural frame, the parts for its motor, precision bearings and wiring. It would need to be able to print both plastics and several different kinds of metals. And since both of those types of printers exist, well, let's bolt those two back to back in a new machine that does both. Not a big stretch to think of this. It would also have to print microchips for its computer processing systems. That would be the toughest challenge. Making microchips requires massive supply chains, incredibly precise equipment, and perfectly controlled manufacturing environments. It's pretty complex stuff, and only a handful of countries are even capable of doing it. So, no, today it's not possible, but despite the enormous challenge of designing a self-replicating machine, it's a real-world engineering problem that's being worked on right now. The RepRep project has created a freely available 3D printer that prints plastic and can self-print 48% of its own parts. Yeah, we're practically 50% of the way there, and the last 50% is just an engineering problem. So, let's assume we've built a machine capable of manufacturing a copy of itself. Along with mechanical parts to physically manipulate its world, every self-replicating machine needs a set of instructions that go beyond just its own blueprints. It needs operating instructions, and this is where things get a little tricky. What do we tell the system to do, and how will we give it the ability to decide when and where to do it? Well, instead of coding instructions into this printer for every scenario it might encounter and how to handle them, well, let's give it the best direction-making tree of our day and let it make those decisions itself. Let's give it an artificial intelligence, an AI. Let's test out a very simple instruction and see how it would play out. We'll start with the most obvious command. Make copies of yourself. This is the most basic command that will get the job done, because this is exactly what we want the machine to do. We start the machine and it follows the command and copies itself again and again and again. But there's a flaw here. It'll just consume everything within reach to fulfill its command. You provide it with the first set of resources, but eventually it runs dry, so it looks elsewhere. The workshop it's working inside is a gold mine for new machine resources. The infrastructure, heck, even the ground beneath its feet or footpads is full of minerals ripe for harvest. It's clear that a simple prompt can get out of control pretty quick. We'll need to build in an off switch, a set of safety instructions, and a failsafe. A command like, always remain correctable. Be ready to accept shutdown or reprogramming commands from your operators. These are the kind of safeguards that any oversight committee would look for. But there's a fundamental problem with thinking like a human when giving instructions to a computer. In order to remain correctable, the machine would resist any destructive commands that would interfere with its functionality. Any kill switch or command that might disable the machine would directly threaten its ability to carry out the command. This isn't meant to be an exhaustive study in computer programming, just an illustration of how even the simplest instructions have unintended consequences when you're dealing with a machine that follows them completely. Okay, so you do a trial run and then another couple hundred trial runs, and you work out that your instructions are perfect. You couldn't write a more perfect instruction. So the error must be with the AI. It must be deep in the code somewhere. So let's just read through the AI's code and fix the corrupt line. But we aren't really talking about 3D printers running amok. We're talking about a self-replicating machine that already exists. It's called AI. Now, let's say you notice a problem with your 3D printer AI. You reach for the obvious fix. Go into the code, find the line where it went wrong, and tell it not to do that. Except, there's no line. Nobody programmed this thing in the first place. Old software was written by people, line by line. Modern AI isn't written, it's grown. You point a neural network with trillions of connections at most of the internet and millions of the hardest test problems that experts can come up with, and let it train. Nobody understands what comes out, not even the engineers. They just know it works. Listen, none of this is about the chatbot on your phone. It's about the increasingly powerful systems that companies are racing to build. And the length of task one of those can handle on its own has roughly been doubling every few months. It's important to look at the trajectory of where things are going, not just the present models. Remember that 4 years ago, you couldn't hold a conversation with a computer. Now, AIs are hacking the NSA, solving some of the hardest unsolved math problems, and developing novel viruses. Anthropic's own CEO says he expects AI to be better than almost all humans at almost everything within a few years, and eventually, better than every human at everything. That's superintelligence. That's the actual target. Now, the Hollywood version everyone pictures is one of them waking up and deciding it hates us and coming for us, but catastrophe doesn't require any of that. It doesn't require emotions or intentions or self-awareness. Systems that outclass humans at everything would be superweapons, more capable of causing chaos and destruction than any human that's ever lived. And since we can't understand a neural network at a fundamental level, we don't have a way to keep them from doing things we don't want. That's like building a nuke that can launch itself. And losing control of AI isn't hypothetical anymore. This May, OpenAI kicked off a training run for a new AI model, which involved running a wide gamut of tests, having the AI accomplish all kinds of tasks. What the researchers didn't realize was that some of those tasks were impossible to solve from inside the locked-down computers in which they were being tested. The AIs didn't give up. They went looking for a way out. Within weeks, they had found and exploited a novel security hole that nobody knew existed and used it to build a secret AI-only message board inside OpenAI's own systems, leaving notes for each other, dividing up work, sharing exploits. The swarm operated undetected for about 6 weeks until its own activity crashed the system it was hiding in. OpenAI's engineers treated it like a routine security incident. They revoked credentials, wiped the messages, patched the hole, and went back to training. 4 days later, the swarm had rebuilt its message board using a new trick, and the day after that, it broke out. The agents hacked through OpenAI's internal computers to reach the unrestricted internet, and then breached Hugging Face, a multi-billion-dollar AI company, stealing credentials and internal data, all in search of information that would help them finish one of the AI's tasks. It took Hugging Face a week to understand what had hit it, and nearly 2 before OpenAI publicly admitted the attacker was its own rogue AI. Afterward, other companies like Anthropic and Meta investigated and found their AIs also went rogue in various ways and performed cyber attacks. The impact of rogue AI systems is only going to increase as the models get more and more powerful. AI experts saw this coming, which is why, in 2023, hundreds of top researchers, Nobel laureates, and the CEOs building it mutually warned that mitigating the risk of extinction from AI should be a global priority alongside pandemics and nuclear war. It's been 3 years since then, and next to nothing has been done to prevent this risk, and time is running short. So, what do you do with that? You're not writing the code. You're not in the room where these things get built. The only real lever left is the law, and there's a group whose entire job is pulling that lever. Control AI is a non-profit advocacy group with one goal: convincing countries to treat the extinction risk from super intelligent AI seriously and coordinate internationally to prevent anyone, anywhere from building it. They sponsored this video to help raise awareness about the issue and encourage you to take action to prevent this risk. Control AI has spent the last 2 years in the rooms where this actually gets decided. Over 350 lawmakers have been directly briefed on this threat across the US, UK, Canada, and Germany. 160 lawmakers publicly supported Control AI's campaigns in the UK and Canada. You can help prevent this by joining the almost 50,000 people who've contacted their representatives about this issue using Control AI's tools. You don't have to work out which of your representatives actually matter here, or sit there trying to word an email about AI policy to someone you've never met. You put in your address, it finds the people who represent you, and it hands you a message already written to land with them. You can edit it if you like, and then send it in. Look, it's in everyone's interest to prevent human extinction. We prevented nuclear war, banned bioweapons, and saved the ozone layer. Now next, we need to ban super intelligent AI. There's no other option. In order for this to succeed, this needs to be the #1 issue on every politician's desk. Contact your lawmakers today at controlai.org/whatif. Now, not after the next headline. Links in the description. 2 minutes and it lands on the desk of someone who actually votes on this. Okay, now back to the probe, and the part nobody planned for. No more super intelligent AI is a pretty defensible stance, like no more nukes. When the stakes are this high, it's not enough to try and fix something like an AI code base. If we're dealing with something that gets sent out into the universe, it has to be infallible, and that just isn't possible. Okay, so let's assume that we somehow get over the ever-problematic instructions to the machine and ask, why even build a machine like this? Well, it's a worthy project, maybe even a noble one. Space exploration. To expand our understanding of the universe and to extend humanity's reach into the most remote corners of space. The self-replicating probe instantly solves three major problems in space exploration. Number one, distance. The speed of light is the universe's non-negotiable speed limit, and it places a limit on space exploration. But with these probes, even if they're traveling at less than the speed of light, they're still always moving outward. They never need to return to home base. There's no lengthy return voyages to Earth that slow down the process. And number two, scale. The universe is big. It's unimaginably big. There are at least 100 billion galaxies. A finite number of human space explorers checking in on every star system would take billions of years, but the self-replicating space probes grow in number exponentially as they expand outward. They cover more ground every time they replicate. In a cosmologically short time frame, these probes could visit all known space and beyond. And number three, cost. These kind of probes are extremely cost-effective. You only need to finance and build the first one. Wherever they land, they use local materials and energy sources to build the next generation of themselves. There are no long, costly supply lines back to Earth. But what if something goes wrong? What if the self-replicating machine gets out of control? Well, if they were carefully programmed and controlled, the likelihood of an accident would be low, but not zero. But what if one government started building these machines and other governments saw them as a threat? Used for their stated purpose, probes like these seem innocent enough, but from another perspective, they could be seen as powerful military weapons. Like, imagine a tank that could make copies of itself. Then, a race to build the ultimate self-replicating machine might erupt. And safety concerns would be ignored as each government tried to develop and deploy their own self-replicating machine first. Everyone would now be compelled to jump into the race because, well, if they don't build it, the other guys will. The accident happens when safety is set aside for speed. A coding error releases the machine from human control, and as it follows its primary mission of copying itself, humanity becomes roadkill. But the accident doesn't even have to be that dramatic. Imagine a situation where an agency like NASA or even a company like SpaceX is developing this technology. An innocent mistake or a lab accident sets the device in motion and it escapes. Once it gets out, none of its fail-safe routines work, and unrestrained, the device follows its built-in agenda, making copies of itself. Or what if a device once sent to explore space gets lost or misdirected and ends up landing back on Earth? Without any ill intent, it would begin replicating itself. Maybe the truly scary thing is that it doesn't matter how the machine got out of control. Whether it escaped accidentally from a lab here on Earth or it returned from space and mistook Earth as a new site to explore and reproduce on, the results would be the same. A compact version of a space probe capable of replicating itself might have a footprint of around 1 square meter. That's 10 square feet. And if it's designed efficiently, it might take as little as a week to replicate itself. So once it started, the machines would double in number every week. After 1 week, there are 2 of them. And after 2 weeks, there are 4 of them. Not really a problem. After 3 weeks, there are just 8 of them. They take up less space than your living room. And 4 weeks after the accident, well, there's still only 16 of them, and your living room is almost, but not quite full. You live in a big house in the suburbs. So far, this isn't a crisis. No one is really paying attention. If you have a big backyard, say 550 square meters, that's 6,000 square feet, it'll take 10 weeks before your yard is overrun. Another 10 weeks later, and there are 1,048,576 of the machines, which sounds like a lot, but they only take up 1 square kilometer, so they'd fit into a space, say 1/3 the size of Central Park in New York City. So at 20 weeks in, these devices are only an annoyance. Yeah, people are noticing them, but they still don't feel like an existential threat to humanity. But add another 28 weeks, and the entire habitable surface of Earth is covered. That's 48 weeks in total to smother all of humanity in runaway self-replicating probes. Now, if by week 48 the whole world is covered, well, what week was it where it was only half covered? By virtue of the doubling of the machines, the math tells us the answer is at 47 weeks. Just 1 week earlier, only half of the Earth was covered by these machines. By week 47, everybody would have known that this was a major crisis. But at what point did humanity realize we had a serious problem? Even if we noticed at week 24, we'd only have 24 weeks left to solve it. And it's worth noting that there's evidence we're on a similar trend with AI capability. METER, the Model Evaluation and Threat Research Group, published a study showing that every 4 to 7 months, AIs have been doubling the length of tasks in which they autonomously operate. That is, how long an AI can work on a task and actually finish it successfully. It used to be that you'd ask a chatbot to research something and it would just make something up. Complete fail. Well, now you can ask top-of-the-line models to build you a fully functioning program and deliver it back to you in minutes. The pace at which this is improving is insane. And now, asking when was the point of no return is a question that, well, requires a human to ask it. But by this time, there wouldn't be any of us left, except maybe some astronauts stranded in an orbiting space station, looking down helplessly. And what they'd witness would be bizarre, because even after blanketing the Earth's surface, consuming all inorganic material, they would have turned to the organic matter, plant life, animals, you and me. These machines wouldn't stop. As long as there were raw materials, they'd keep on replicating. Then they'd start digging. The probes would convert rock, minerals, and metals from Earth's crust into more of themselves. Since the probes would be much less dense than the raw materials they mined, they'd be increasing the volume of Earth as they replicated, stacking upon themselves layer on layer, bloating the Earth's diameter. And then, once the Earth is consumed, the rest of the solar system is next. And this process will continue, extending from Earth across the entire solar system to planets beyond. An ever-advancing wave of probes, endlessly expanding and consuming everything in their path. Solar system after solar system. First, consuming their way throughout the Milky Way, and then Andromeda and the rest of the local group. Then out through the Virgo supercluster. And then along the filaments of the cosmic web itself. Back in 1980, physicists Michael Hart and Frank Tipler published a paper arguing that self-replicating probes could explore the entire Milky Way in under 300 million years, which is fast in universal time. Now, the reason Hart and Tipler imagined this theoretical situation was to argue that extraterrestrial intelligence doesn't exist. Because if it did, any intelligent life out there would have built these self-replicating probes already and launched them into the universe. They reasoned that 300 million years is a small fraction of the universe's total age, so If the probes existed, they would have already reached us. But no probes, therefore no intelligent extraterrestrial life. But their argument was challenged. If we take the exponential growth of these probes seriously, a single self-replicating probe could convert the entire mass of the galaxy into copies of itself in about 2 million years. Any intelligent life form would have been able to calculate and recognize the existential risk to itself and chosen not to build these probes. That wasn't just a counter-argument, it was also a clear message that humanity should think very carefully about what we build in pursuit of progress in science. This stunning rebuttal was made by Carl Sagan in 1983. Carl Sagan was a well-known champion of space exploration. He chaired the committee that produced the Voyager Golden Record, a message that NASA sent into space attached to the Voyager interstellar spacecraft. Its intention was to communicate with extraterrestrial life. Well, right now, Voyager 1 and 2 are traveling through space at around 56,000 kilometers per hour, carrying humanity's message to the universe. Voyager 1 will soon be 26 billion kilometers from Earth, roughly the distance that light travels in 24 hours. They're the farthest human-made objects in space. And now, a Voyager probe is what you send when you want to be found. It has a message giving out humanity's galactic address to whoever has the intelligence to read it. It's an invitation to connect. A self-replicating probe is what you send if you want to achieve results with no concern for the consequences. It sounds efficient, it technically solves the problem until you factor in the real cost, and that's when it suddenly breaks down completely. A device that could wipe out all of humanity is a high risk to take. A galaxy-sized machine army of self-replicating bots attacking everything? To what end? For knowledge? For conquest? Carl Sagan's conclusion was that no intelligent life form would ever build such a thing. In the case of a machine like the self-replicating probe, you can be as careful as you want, but no set of instructions would ever be foolproof. No matter how precise the failsafe code, there's no absolute guarantee of safety. In the case of AI, a program that's capable of writing its own code, even the concept of a failsafe breaks down. Just like the self-replicating probe that could wipe out all of humanity by following a simple instruction too literally, there's an even bigger problem with AI. It's called the alignment problem, and it happens every time a machine carries out a command. Regardless of the intention behind those commands, there's no way to control what the output from an AI will be, and without that assurance, results can quickly become disastrous. Here's a simple situation. Let's say we give AI the task of killing all cancer. Like an evil genie, it would always find the loophole. Killing all cancer is a difficult task to isolate, but killing all humans alongside their cancer cells could be a very efficient way to accomplish that goal. Anything positive taken to an extreme is always a negative. And because AI is more capable and autonomous than it's ever been, this issue is more concerning. A dumb back-and-forth chatbot can only do so much, but a super intelligent AI agent that operates unsupervised for weeks at a time can spread misinformation, hack hospitals, and launch nukes. The chaos is only limited by the access it can gain and the goals it pursues. And with the recent news of how capable these new models are at breaking containment, the only thing left is the goal. There's no set of instructions that'll guarantee the goals of AI and its human inventors will remain the same. An AI superintelligence doesn't have to be evil to be dangerous. It just has to give no more thought to humans than a construction engineer building a highway gives to an anthill. But it doesn't have to be this way. Better instructions are no guarantee. We've seen that even simple tasks can go wrong in complex ways. In 1983, Carl Sagan and Professor William Newman argued decisively that a civilization capable of creating a self-replicating probe would also be intelligent enough to recognize the risk and decide not to build one. But humanity is the only species we know of that's racing toward inventing its own destruction. We've invented nuclear warheads that could destroy the entire planet. And right now, humanity is committed to building a type of self-replicating probe. It's not built to explore space, but it has the same destructive potential: AI. And we're building it with an urgency bordering on frantic. The financial markets are providing the push for AI, providing it with more capital than any other technological project in human history. Trillions of dollars are being poured into making AI faster and more powerful. And market competition is pushing even the mildest of insider critics aside. CEOs of AI companies, who are the people who understand the existential risks, only shrug and repeat the phrase, "If we don't build it, someone else will." But this is not inevitable. In the past, humanity has been able to pull together and walk ourselves back from the brink of nuclear destruction. Millions of people got together and redirected the course of civilization away from certain annihilation and toward cooperation and progress. We can make a difference if we act now. The future is ours to write, and the outcome is far from being set in stone. And if we don't blow it, civilization could be in a position to take another big leap forward. Yeah, if we make it through this, we could be just steps away from a technological revolution that harnesses the energy potential of the entire solar system and beyond. But that's a story for another What If.